And our last lecture here is on protein metabolism. This is a pretty short lecture. Protein metabolism, at least in the Krebs cycle, again, a lot of proteins will be broken down into their amino acids, and then those amino acids might actually get utilized for anabolic processes like building new cellular tissue, making new enzymes, making new hormones, building the immune system. But in the event that the amino acids need to be utilized for energy, we have what are called glucogenic amino acids and ketogenic amino acids. So basically these amino acids up top, these are glucogenic amino acids. The ones that are in, actually all the green boxes are typically our glucogenic amino acids. Coming into the, basically making pyruvate or coming into the Krebs cycle. We also have what we call ketogenic amino acids, which come into the more fatty acid. Basically, they can be converted into fatty acid substrates. So leucine, lysine, phenylalanine, tryptophan, tyrosine, isoleucine, leucine, tryptophan. So these might be converted into acetyl-CoA or acetyl-CoA. So basically, the amino acids can flow into this whole Krebs cycle program, whether they do it through the more of a glucose precursor or whether they do it through more of a fatty acid precursor. And then also remember that with all amino acids, we have to see this process of oxidative deamination, where we pull the amine group off of the amino acid, send it to the liver to be converted to urea, and then send urea out to the kidneys to be excreted. Because again, ammonia is toxic to the body, so we need to get it, we need to detoxify it. The liver is the site of detoxification of everything, and then get rid of the urea. So one thing you can actually measure in your blood if you visit your primary care regularly, or not regularly, but if you've had blood work done, you can actually measure blood urea nitrogen, which is showing how much urea is existing in the blood, which is basically can be either an indication of how much protein you consume. So if you consume a ton of protein in excess of what your body's utilizing, you'll see pretty high blood urea nitrogen because your body needs to get rid of that excess ammonia. But in the case of pretty severe sickness too, where the body might be, or even severe starvation where the body might be breaking down its own body proteins, you might also see blood urea nitrogen there too, or elevated blood urea nitrogen. So I think slide here, and that's it for this lecture. But remembering just that carbohydrate is the primary source of energy for the body, and fat would be the secondary source. Protein is very last resource for making energy. But as we just said, amino acids can enter the Krebs cycle or the tricarboxylic acid cycle, either through glucogenic pathways or ketogenic pathways. So glucogenic would be where the amino acids are converted to pyruvate, and then ultimately pyruvate to acetyl-CoA and flow through the Krebs cycle. Or the ketogenic amino acids, like I showed you, would be converted to acetyl-CoA and flow through the Krebs cycle. If we have calories in excess, the carbon skeletons, whether it's glucose, fatty acid, or amino acid, will be converted into fatty acids and stored in adipose tissue. And then proteolysis, just like lipolysis or glycolysis, is the breakdown of the protein to release the amino acids. So I would encourage you at this point too to go back and look at even if you already looked at the metabolism lectures, I'd go back and look at them again, because basically to sum up everything we just talked about the carbohydrate, fat, and protein metabolism. So just to help yourself remember, okay, so we start with either proteolysis, glycolysis, or lipolysis, and then ultimately we're creating acetyl-CoA and sometimes also pyruvate. And then if we also have pyruvate, we make oxaloacetate, and then we see the cycle through the Krebs cycle. the generation of the NADH and the FADH2 molecules, the coenzymes, which then pass their hydrogen atoms and their electrons off in the electron transport chain, and we make this big hydrogen ion concentration gradient, and then we pass all those hydrogen ions back through ATP synthase, and thus, in the final process of oxidative phosphorylation, generate ATP. So understanding that the acetyl-CoA, the Krebs cycle, the electron transport chain, and oxidative phosphorylation, that happens regardless of whether the substrate was glucose, fatty acid, or amino acid. So understand that that end process of metabolism is the same regardless of what the substrate was. It's just a matter of, do we also see proteolysis or lipolysis or glycolysis? So just please go back and review the two lectures on metabolism.